a total of 15 questions. Then 1 to 4 will be 1 mark questions. Then question number 5 to 9 we will have 2 mark questions. Then question number 10 to 14 we will have 3 mark questions. And then question number 15 is 4 marks. Okay, so total marks are 33. Total marks are 33, and duration you can say we should be able to finish in 1 hour. Okay, so we'll start with our 1 mark questions. Okay, so now let's see, we'll have a question number 1. So let's go to question number 1 directly. That's a 1 mark question. So 1 mark question we can start. Okay, so in first question it says, in a sample study of 642 people. Okay, so from here only, by reading the question only, I can find out that my total number of outcomes are 642. Okay, then it was found that 514 people have a high school certificate. That means they have done their high school studies, right? High school certificate. Okay, now if a person is selected at random, the probability that the person has a high school certificate is, okay, it's a multiple choice question. So my first is 0.5, second is option, or I can write down as A, B, so this becomes 0.6, and my C is 0.7, D option is 0.8. so I have to figure out. So I know it's a multiple choice question, so you think that you can just write down the option, but you can't do, because directly you can't find out the answer. You have to write down, right? So I would say my solution has total number of outcomes, right? So total number of outcomes are how many? They are given in the question as 642 directly, and then people who have high school certificate, so that is my favorable outcome. So number of favorable outcomes are directly given, so they are equal to 514. Okay, so my probability of that event will be equal to number of favorable outcomes, right? Favorable outcomes by total number of outcomes. So that is my probability. For these multiple choice, you don't need to write down the formula, but suppose if multiple choice question was not there, then definitely you have to write down. Okay, so probability of a person having a high school certificate, right? So probability of having a high school certificate will be equal to 514 by 642. Okay, so I have to reduce this. So 2 to the 4, to 5 is 10, to 7 is 14, 2, 3 to 1. Okay, now I don't see any close number which is common in these. So instead of I can just divide 321 and 257, right? Okay, so 0 point, and this will be 0, so it will go first time 8 times, I know this. Okay, so I can see my options. I have 0.8, right? So, and 0.9 is not there. So if I go to second decimal point, and then suppose if it is, I know here it won't be more than, it will be I think only 1. So okay, 8 ones are 8, 8 2s are 16, 1 carry 25, this, so 2. So it won't be more than 1 here for the second decimal point. So now I can just see my answer is D, right? D is my option and answer is 0.8. So you have to write down in multiple choice questions, you have to write down both the option as well as your answer to get full marks. Okay, so now question number 2. Again, 1 mark question here. It says a coin is tossed 500 times. A coin is tossed 500 times. Okay, with the following observations. Okay, with the following observations, or the observations which are given here. So observations are: head is 245 times, and I have tail is 255 times. Okay, so now the coin is tossed again. The coin is tossed again. Okay, what is the probability of getting a head? So what is the probability of getting a head? Okay, so we have to find out what is the probability of getting a head here. So now again in the solution, okay, so solution, I can say, again I have to write down what are my total number of outcomes. So total number of outcomes. Okay, so total number of outcomes are how many here? 500 given. Okay, now my favorable outcomes. So favorable outcomes here are probability of getting a head. So my favorable outcomes will be, number of favorable outcomes will be equal to 245 given in the question directly. So 245 times we are getting a head. So that is the, so now again we have to write down the formula for probability. So probability of an event is equal to number of favorable outcomes by total number of outcomes. Total number of outcomes. Okay, now so my probability of getting a head will be equal to 245 by 500. Okay, so now 5 8s are 40, 5 9s are 45, 5 how many times? Oh, sorry, 5 4s are 20 and 100. Okay, so this is equal to, either you can write down as 49 by 100, or you can just write down 0.49 also. So both are my answers. Okay, now let's move to question number 3. So question number 3. Okay, it says blood groups are recorded in his class, right? So the following blood groups are recorded. The following blood groups are recorded in a class. Okay, so the table is given to you. Okay, let me make the table. So my table is like this. Here I have blood groups. Okay, and here I have number of students. Okay, so now here the blood group is A and number of students are 10. Blood group is AB, then my number of students are 13, and if my blood group is B, number of students are 12. If my blood group is O, then my number of students are 5. So this table is given to me in the question. Okay, now the question is, a student is selected at random. A student is selected at random from the class. The probability that he or she has blood group B, is, okay, this is a multiple choice question again. So A option is 1/4, B option is 13/40, C option is 3/10, and D option is 1/8. Okay, so now let's see the solution. We'll go to solutions now. So solution says blood groups are given, right? So total number of outcomes I have to find out first. So my total number of outcomes first. So because they have not given directly, I have to add all of those, right? So 10 plus 13 plus 12 plus 5. So how much does it come out? 15, 25 and 30 and 40. So this comes out to be 40. Okay, now they say blood group B. So my favorable outcomes. Okay, so my favorable outcomes, number of favorable outcomes will be equal to, they have given directly in the table. So B is 12, right? So of getting blood group B is equal to 12. Now my formula, probability of an event is number of favorable outcomes by total number of outcomes. Okay, then so my probability of getting the blood group B will be equal to 12/40. So 4 3s are 12, 4 10s are 40. So my answer will be C, 3/10. Again, you have to write down the option as well as your answer in multiple choice questions. Okay, so now let's move to question number 4. So question number 4 says 2 coins are tossed 1,000 times. 2 coins are tossed 1,000 times. Okay, and the outcomes are again a table is given to us. So number of heads, and then I have frequencies here. Okay, so suppose if I have 2 number of heads, like on both the coins, correct? So it is 200. Then suppose if I have 1, then it is 550, and if it is 0, then it is 250. So this table is given to us about the observation if 2 coins were tossed. Okay, so now you have to find the probability for at most. Okay, remember this, at most 1 head. Okay, is. Now again this is a multiple choice question. So A is 1/5, B is 1/4, C is 4/5, and D is 3/4. So these are my options. Again, so we'll move to our solutions. So solution will say, first I have to find out the total, they are given directly. So total number of outcomes are 1,000. Okay, that's 1,000. Now number of favorable outcomes. So number of favorable outcomes here is number of favorable outcomes. Okay, here you have to remember at most 1 head, means it can be less than 1 head also. So 1 head is 550 and 0 head is 250. So I have to add both of these two because they said at most one. Okay, so now this will be equal to 550 plus 250, so that gives me 800. Okay, so these are my number of favorable outcomes. Now my probability of an event is equal to number of favorable outcomes by total number of outcomes, Okay, so probability of getting at most one head, Okay, so this will be equal to 800 by 1000 because total number are these, so 2 zeros, 4 twos are 4 fives. So my answer is 2 by 5. So I have to write down this 2 fours are, sorry guys, okay, 2 fours are 8. Okay, so let me correct it. Okay, so 2 fours are 8 and 2 fives are 10. So that is my option, but it is a multiple choice, so you have to write down answer as option as well as your answer. Okay, so this is done. So I think now all 1 mark questions are done for us. Now we'll come to 2 mark questions. So fifth question is 2 mark question. We start with that. In this it says a coin is tossed 1200 times now. Okay, with outcomes as head is 455 times and tail is 745 times. Okay, so this makes 1200. Yeah, now you have to find out the probability of each case, or they said compute or find out the probability for each case. Each case means how many cases are there in this? 2 cases, right? So getting a head or getting a tail. So we'll move to our solution now. So let's have the solution here. So now solution is total number of outcomes directly given, right? So total number of outcomes, they are directly given as 1200. Okay, now each case, right? So first I'll write down my formula for probability of an event is equal to number of favorable outcomes by total number of outcomes, right? Okay, so I'll take both, right? So for getting a head, so first option I'll take for getting a head. So now I can say my number of favorable outcomes here for this case. Number of favorable outcomes are how many? For getting head is 455, right? Okay, so now my probability of getting a head will be equal to 455 by 1200. So this is equal to 4 ones are it will go by 4 or 5 will start with it won't go by 4, it will go by 5. So 5 nines are 45, 5 ones are 5, and 5 2 4 0, right? So 91 by 240, that will be my answer. Okay, now I'll take the second option as this. So for getting a tail, okay, so here my number of favorable outcomes, they are given directly. So number of favorable outcomes are how many here? 1200, so 745. Okay, so we have 745. Fine. So now my probability of getting a tail will be equal to 745 by 1200. Okay, so this again 5, they both go by 5, so 5 ones are 5 and 5 fours are 20, 5 nines are 45, and 5 240, right? So that is 149 by 240, that will be my answer. So I have found out both the cases. Okay, let's move to next question. So next question is question number 6. Okay, that is also a 2-mark question. So question number 6. A coin is tossed now 1000 times. Okay, with the following frequencies. With the following with the frequencies. Okay, as head is 455 and tail is 545. Okay, now again like the same question, similar question as the last one. So now you have to compute the probability of each event. Of each event. Event is like how many event is getting a head or getting a tail, correct? So that is there. So now let's move to solution of this question. So solution, we know first we have to write down total number of outcomes. Total number of outcomes. So how many total number of outcomes are there? 1000, right? Okay, and I have to compute for both of them. So I'll write down my formula of probability here only. So number of favorable outcomes by total number of outcomes, by total number of outcomes. Okay, so with this for both I'll just set. So for getting a head, first I'll calculate getting a head. So now number of favorable outcomes here, number of favorable outcomes is number of getting heads is equal to head is 455 times. So 455 times. So my probability of getting a head is equal to 455 by 1000. Okay, so now either I can write down in the decimal or fraction. So okay, let's try with. So 5 9s are 5 1s are, and this is equal to 200. So 91 by 200, or I could just directly write down 0.455 because 3 decimal points are 3 zeros are there, so 3 decimal points. So that will be my answer. Okay, now second part I will just say for getting a tail. Okay, so now in this case number of favorable outcomes are 545. Yes, 545. 545. So my probability of getting a tail will be equal to 545 by 1000. Okay, so again the same way, 5 1s are 5 and 5 9s are 45, 5 200, or I could just write down 0.545. so anything would be my correct answer. Nothing is wrong, nothing is both are right. Okay, now let's move to, this was also a 2-mark question, so let's move to now next question of 2 marks. So that is question number 7. Okay, so question number 7 says when a coin is tossed 500 times. Now coin is tossed 500 times. Okay, the outcomes are okay, so what are the outcomes? Head will be 270 times and tail is 230 times. Okay, now if a coin is tossed, what is the probability of getting, what is the probability of getting a head? Okay, so in this case we are just asking the head. So now I'll move to my solution. Let's go for the solution. So solution says first I'll write down total number of outcomes. So total number of outcomes will be equal to how many? 500 here. Okay, Now they are asking for head, so first I'll write down my formula. So probability of an event is equal to total number of outcomes by total number of favorable outcomes, right? Favorable outcomes by total number of outcomes. Okay, so number of favorable outcomes by total number of outcomes. You can just write down number of favorable outcomes. Okay, now so my probability number of favorable outcomes I need to find out. So number of favorable outcomes are how many? Now number of favorable outcomes, favorable outcomes. So number of favorable outcomes are how much? 270, because they are asking for head, so 270, right? Because they said head we are getting 270 times. So my probability of getting a head is equal to 270 by 500. This just gets cancelled, so 27 by 50 is my answer. Okay, this is done. So we are doing the 2-mark questions. So one more 2-mark question, question number 8. This is also 2-mark question. In this question they are asking 2 coins are tossed simultaneously. 2 coins are tossed simultaneously. Okay, simultaneously 500 times. Okay, following are the outcomes. Okay, so these are the outcomes. So we have no head. So no head will be 100 times. Okay, one head is 200 times. Okay, 2 heads. So I'm getting 2 heads again 200 times. Fine. Now if 2 coins are tossed again, if 2 coins are tossed again, okay, compute the probability. Compute the probability of getting or obtaining anything, right? So first will be 1 head, or second is 2 heads. Okay, so I have 2 parts in this. Now we'll move to solutions. So solution is total number of outcomes. So what are my total number of outcomes in this question? Are 500. Okay, and we are given, so we have 2 parts of it. So first I'll write down the formula, so I don't have to write for each part. So probability of an event is equal to number of favorable outcomes by total number of outcomes. Okay, so this is my formula. Now first part I'll go to. So first part says 1 head. Okay, so number of favorable outcomes, for getting 1 head. So they have already given in the question is 200 times, right? So probability of getting 1 head will be equal to 200 by 500. So this is equal to 2 by 5. That's my answer. Okay, second part they are saying 2 heads, right? 1 head and they asked for 2 heads. So 2 heads. Okay, so for this case, this event, a number of favorable outcomes are how many in this case? Even 200. Okay, so now my probability of getting 2 heads is equal to 200 by 500, the same, right? Okay, so this is also 2 by 5. That's my answer. Okay, so now one more 2-mark question. So question number 9. This is also 2-mark question. So a die is rolled 200 times. A die is rolled 200 times and outcomes are recorded. Okay, so outcomes are given in table. Okay, so let's move to this table. So table we have outcome here and frequencies here. Okay, so this is my table. So 1 2 3 4 5 6, because a die, so we have 6. So we have for 1, then we have for 2 3 4 5 and 6. Okay, so these are my outcomes. So they are given as 1 is 25 and 2 is 35, 3 is 40, 4 is 28 and 5 is 42, 6 is 30. Okay, so I'm just adding all these frequencies, so I know it is 200 times only. So 25 and 35 is 60, 40, 100, 170, 89. Okay, so 200 is there. So I just checked for that. Okay, so now the question is, find the probability of getting. Find the probability of getting. First is an even prime. Okay, even prime. Then second is a multiple of 3. I'll go for even prime number. But first I would like to explain what prime numbers are, because sometimes it's not clear to many students. So prime numbers are those numbers. Okay, so if I say prime numbers, okay, so prime numbers are those numbers which have 2 factors. Okay, 2 factors means 1 and number itself. Okay, so these are the 2 factors it should have. So 1 is neither prime. Okay, and nor it is a composite number. Nor it is a composite number. So not it's a prime number, no, prime number. Okay, so it's not a prime number. So we have to take care of this when we are doing any prime number question, that what are prime number this, because many people have confusion about 1, and sometimes they can ask you the question about composite number also. So it's 1 is neither prime. Otherwise some definitions it is there that composite numbers are those numbers which are not prime, but 1 is not prime, so they can consider sometimes 1. So except 1, we should say, when we are defining it like that. So now I think that's clear. So now I'll start doing my questions. So my total number of outcomes, right? So this was a part of explanation for prime numbers. So now total number of outcomes. How many are total number of outcomes? They are 200. Okay, and again I need to write down the formula for probability. So number of favorable outcomes by total number of outcomes. Total number of outcomes. Okay, so this is fine. Now I'll move to one first part. So it says an even prime number, probability of getting an even prime. So there is only one prime number which is even, others are odd, and that is 2, right? So getting 2, I can write down like that, getting 2. would be getting a prime number. So 2 is 35 times. Okay, so my number of favorable outcomes are 35, right? So probability of getting an prime number will be an even prime. Okay, an even prime number will be equal to 35 by 200. So now my answer, I can go 7 and 540s are correct. So my answer will be equal to 7 by 40. Now I move to second part. So second part says a multiple of 3. A multiple of 3. So how many multiples of 3 are there in this? Only two things, 3 and 6. So 3 is 40 and 6 is 30. So I can say my number of favorable outcomes, right? So number of favorable outcomes are getting 3 is 40 times and getting 6 is 30 times. So this is equal to 70. So probability of getting a multiple of 3 will be equal to 70 by 200. So this will be equal to 7 by 20. Okay, so this is the first answer. This is my second answer. So now we are done with the 9th question, and we can see that we are done with our 2-mark questions. So let's move to 3-mark questions. So 3-mark question number 10. So question number 10 says three coins are tossed 30 times. 30 times simultaneously. Okay, each time the number of heads occurring was noted down as follows. So whatever 30 observations were there that I need to write down. So these were 0, 1, 3, 1, 3, 0, 2, 1, 0, then 2, 1, 1, 1, 2, 1, then 2, 2, 2, 3, 0, 3, 1, 1, 2, and 3, 2, 2, and 0, 1, 0. So I've just moved from the question, the last column to first column. It's okay. So now these are my observations for getting the head, right? Okay, so this is my observation. Now you have to prepare the frequency distribution table. So prepare the frequency distribution table. Okay, so now frequency distribution table. So 3 coins. So there are chances of 0, 1, 2, and 3. So I can write down getting heads, right? So that will be number of times 1, 2, and 3. Okay, then here I can make a column for telemarks. Always you have to write down telemarks. Okay, so telemarks we have to make bundles of 5. So I'll just move to this. Okay, so first I'll have I have 0, so 1, then 1, then 3, then 1 again, and then 3. You have to keep putting the finger on the numbers and just keep moving. 2, 1, 0, 2, 1, 0, then 2, 1, 1, 2, 1, 1, then 1 to 1, so 1 to 1. Okay, then 3 times 2, so 1, 2 and 3 times 2, then 3 0 3 3 0 and 3. Okay, then 1 1 2, so this is 1, this is again 1, and this is 2. Then 3 2 2, so this is my 3, this is 2, this is 2. Okay, 0 1 0, so this is 0 and this is 1 and this is 0. Okay, so I finished doing my telemarks. So now my frequency here, right? So frequency is equal to 6 here, this is equal to 10, and this is 9, and this is 5. So 9 and 5 14. Okay, so whenever you have to make a frequency distribution, always do with telemarks. So these are your telemarks, and always you have to write down sum of frequencies. So sigma f, always you have to write down. So total of the frequencies 9 and 6, 15, 20 and 10, 30. So okay, so we have the number of frequency as 30, and we should write down like that always to finish the question. Now let's move to question number 11. So question number 11 says, following is the data about the months of birth of 40 students. Okay, find the probability that the student chosen is born in June, and second part is not born in June. So that's fine. So we have been given a data. So best way to solve these kind of questions, we can make a frequency distribution table, right? So I have made a frequency distribution table, so which is shown like that. So I know, and this total 40 students, and I have put telemarks, and then I have put it. So first thing, like total number of students or outcomes is equal to 40. Then I have to write down the formula definitely. So probability of an event is equal to number of favorable outcomes by total number of outcomes. Okay, so now we move to first part of the question. So first part, they say born in June, right? Okay, so my number of favorable outcomes. Okay, so number of favorable outcomes are how much? We have made the distribution table, and it has been given in the question also. So that is equal to 40, right? So now we have to find down the probability of not favorable outcomes, sorry, number of total, these are total outcomes. Okay, so number of favorable outcomes are born in June. So there are 9 students which are born in June. So number of favorable outcomes is equal to 9. So probability of born in June I can write down, right? Okay, so I'll write down probability of getting a student who is born in June. So that is equal to 9 by 40. Right, so that will be my answer. Now let's move to second part. So second part says was not born in June. So I would say a student was not born in June. So here again, number of favorable outcomes, or I can also write down as number of students who are not born in June. So those are equal to born in June are 9, total are 40, so 40 minus 9, right? So that is equal to 31. So probability of a student of not born in June will be equal to 31 by 40. That will be my answer. Okay, so this finishes another 3-mark question. Now we'll move to question number 12. Okay, so question number a table is given to us. Again, the number of students are 40, right? So again, month of birth of 40 students, right? So the following table shows the month of, right? Shows the month of birth of 40 students. Okay, here they have given the table, so directly we can just move. We don't have to do the table. Okay, so now shall I make the table now? So table will be months here, and we have January, February, March, April, May, okay, June, July, August, September, October, November, and December. Okay, and number of students. So number of students. So number of students are frequency 3, 4, 2, 2, then 5, 1, 2, 5, 1, 2, 6, 3, and I have 4, 4, and 4. So these are my frequencies or number of students. Okay, so now question first, we have two questions in this. Okay, so now first part of the question is asked, find the probability. Find the probability that a student was born in the month with 31 days. Okay, so first in this case we have to figure out that which months have 31 days, right? So if we go to the months, I think everybody knows. So months with 31 days. Okay, which are the months? So January, February will have 28 or 29. Then we have March, April is 30, May, June is 30, then July and August. Both are 31 days. I used to do on my fingers, like when you close your fist, right? So those, when you start counting, then those mountain kind of things, right? So those are 31 days. So this is how I was taught. My mom told me about this. So January, March, April, May, June, July, August, then September, October, November, and December. So 1, 2, 3, 4, 5, 6, 7 months are with 31 days. Okay, so 31 days are these months. So let's write down the favorable outcomes. First, shall we write down the formula here? Okay, because we started the first part, I think we could have written the formula in the starting only. So number of favorable number of favorable outcomes by total number of outcomes. Okay, so I wrote it here. So now I can just I write down. So number of favorable outcomes. So those will be equal to the students who are born in January, March. Okay, so January is how many? 3. Okay, so January is 3. Then we have March 2. Then May is 5. July is 2. August is 6. October is 4 and December is also 4. So 3, 3, 6, 7 months, and we had 7 months there. 3 to 5, 6, 7. So now we have to make a total of it. So 5 and 5, 10, 26. Okay, so people who are students who are born in the month with 31 days. So those are 26. So now my probability of born in month with 31 days. Okay, so that will be equal to 26 by total students are 40. So this is my answer. Okay, let me move to second part of this now. So second part says, I have not written in the top, but it's okay. So you have to find the probability who was born in the month of February. Okay, so find the probability. Okay, that a student was born, was born in the month of February. In the month of February. Okay, so February is the month. How many students are born? So again, I'll write down my number of favorable outcomes here first, right? Number of favorable outcomes. So number of favorable outcomes here, students who were born in February. Okay, so when I see the table, there are only 4 students who were born in February. So that is equal to 4. So probability of student who is born in February, so that will be equal to 4 by 40. So this is equal to 1 by 10, or I can write down as 0.1 also as my answer. Okay, so this another 3-mark question is over. Let's move to question number 13. So question number 13 now. Okay, so question number 13 says we are given with the frequency distribution table for the salary of 80 workers in a factory. Okay, so it says following table is the frequency distribution table. Frequency distribution table. Frequency distribution of salary of 80 workers. Okay, so total number of outcomes will be 80, and this is my table. So I have salary here and I have number of workers here. So salary is between 1000 to 2000, then 2000 to 3000, 3000 to 4000, and then 4000 to 5000. Okay, so number of workers is 12, 18, 22 and 28. Okay, so these are my thing. Now, if a worker is selected at random, you have to find the probability that his salary is. Okay, so my question says, okay, I can make the lines. You have to this table. Okay, so this is my table. Now, if a worker is chosen or selected at random, anything is fine. You have to find the probability. Find the probability that his salary is. Okay, so first is less than 8,000 rupees. Less than 8,000 rupees. Okay, all these salaries are given in rupees. Okay, rupee sign or RS, anything you can write down. Then second part, more than or equal to. Right, this is a symbol for that. So more than or equal to 1,000 rupees. Okay, so 1,000 rupees. Then third part says more than or equal to 2,000. Okay, so I can just write down like that also, between rupees 2,000, between. Okay, between, or no, this when I'm writing like this, because equal to also they are saying. So if I say equal to, I think that makes sense. That's fine. So more than or equal to 2,000 but less than 4,000 rupees. So between 2,000 to 4,000, right? 2,000 and 4,000 rupees. Okay, that's fine. So now this is the table given to us, and I have to find out first part. So first what I'll do, total number of outcomes, right? So solution, I have to find out total number of solutions, right? So total number of outcomes. So So total number of outcomes are how much? 80. That has been given in the question. Then I have to write down the formula. So number of favorable outcomes, right? Okay, so number of favorable outcomes by total number of outcomes. This formula is important. Every time you have to write down in the starting, so you don't have to write down for each part of the question. So for each question you have to write down, but if there are parts, you can write down once in the starting. So less than rupees 8,000, right? So less than rupees 8,000, correct. Now so I'll have to see my table for number of favorable outcomes or number of workers which have less than 8,000 rupees, right? So let's see the table. Less than 8,000. Okay, I think it will be less than 8,000. Something is wrong here, okay, in the question. So I think it is something else, not 8,000, right? So I think it will be 3,000, not 8,000. Yeah, so some printing mistake. Okay, so 3,000 I can take. This is also 3,000. So now number of favorable outcomes are how much now? 12 plus 18, right? So 12 plus 18, so this is equal to 30, right? Okay, so now my probability of a worker getting less than rupees 3,000, not 8,000, okay, is equal to 30 by 80. Okay, so this gets cancelled and 3 by 8 will be my answer. Okay, now I'll move to second part. So second part says more than or equal to 1,000 rupees. More than or equal to 1,000 rupees. Okay, so 1,000 rupees, if I see the table, all are more than 1,000 rupees, right? Each worker is getting more than 1,000 rupees. So again, my number of favorable outcomes will be all. So number of favorable outcomes on people who are getting more than 1,000 rupees will be equal to 80, because everyone is getting. So my probability of getting more than or equal to rupees 1,000 will be equal to 80 by 80. Okay, so this is equal to 1. Okay, now I move to third part. So third part says more than or equal to 2,000. Okay, so it is between rupees 2,000 and 4,000 rupees, right? So 4,000 and 2,000. So I'll start from my table from this part, 2,000 to 4,000. So I'll add these two, right? So 18 and 22. So because both are getting 18 and 22. Okay, so now my number of favorable outcomes. So number of favorable outcomes is equal to 18 plus 22. So that is equal to how much? 40. Okay, so my probability of a worker who is getting a salary between rupees 2,000 to 4,000 is equal to 40 by 80. So this gets cancelled, 1 by 2. That will be my answer. So again, this was also 3-mark question. We are done with this. Now let's move to question number 14. Okay, so question number 14, what does it say? So question number 14. Okay, it says 1,500 families with 2 children were selected and the following data was recorded. So I can write down that following is the data of 1500 families. 1500. So I know my total number of outcomes are 1500 with 2 children. Okay, now the data is number of girls in the family, number of girls, and then we have the number of families. So total number, frequencies, right? How many girls are there? So if there are 2 girls, there are 475 families. Okay, 475. Let me write it clearly. So this is 475. Okay, then with 1 girl we have 814 families. With 0 number of girls I have 201 families. So we just check that whether the families are 1500 and not. So you can just add the frequencies. If they are equal to 1500, that means we have not made any mistake in counting, or when you are making the frequency distribution table, so for tally marks, right? So you can always count. So now 5 and 5 0, then 3 and 7 10, 1 carry, 6 and 8 14, and 15. So that is fine. Now my question is, you have to find the probability. Find the probability of, so there are 3 parts, 2 girls. Okay, second part 1 girl, third part no girl. Okay, so these are the probabilities you have to find out. Okay, so for my solution I will start with total number of outcomes. So total number of outcomes, so total number of outcomes are 1500, we know this, and I'll write down my formula. So number of favorable outcomes of that event by total number of outcomes, by total number of outcomes, right? Okay, so this is fine. Now I'll move to each part of the question. So first part says I have to find the probability of 2 girls, right? So my number of favorable outcomes in this case are 475. Okay, so 475. So my probability of having 2 girls will be equal to 475 by 1500. Okay, I can reduce it to lowest fraction. So lowest fraction will be 5 9s are 45 and 5 5s are 25, 5 300. Okay, then again it goes by 5. So 5 ins are 5, 5 9s are 45, 5 60. Now I can't reduce, so that will be my answer. Okay, second part it says 1 girl. Okay, 1 girl. So my number of favorable outcomes for 1 girl. So 1 girl, if I go back, it is 814. Okay, so probability of having 1 girl will be equal to 814 by 1500. Okay, so let's reduce it to lowest fraction. So 4, it will go by 4, I know, but let's go by 2 and 2. So 2, how much? 2 4s are 8 and 2 7s are 14. Then 2 7s are 14 and this, right? 750. Okay, then again it won't go by 2 again because the denominator will go by 2. That's not going, so that's fine. So that will be my answer. Okay, now let's move to the third part. So third part says no girl here. Okay, so no girl, number of favorable outcomes or the families which do not have a girl are equal to in the table 211. Okay, 211. So my probability of the families which have no girl will be equal to 211 by 1500. So I can write down this as my answer. Okay, so this was also a 3-mark question, and we have done all 3-mark question. Let's move to last question, and that is a 4-mark question, right? So 4-mark question number 15. So question number 15, a table is given to us. So it says the marks of 90 students, right? So marks of 90 students are, okay, so this is given. So suppose my marks are 0 to 20, 22, 30, 32, 40, then 40 to 50, 50 to 60, 60 to 70, and 70 to 80. Okay, these are all marks out of 100, right? Out of 100. Okay, then number of students, or I can say the frequency of those students. So this is equal to 7, 10, 10, 20, 20, 15, and 8. So this is my table of marks, right? Okay. Okay, this is my table. Now a student is selected at random. You have to find the probability. So find the probability. Okay, of less than 30. A student, if he's got less than 30 marks. Second part, 60 or more marks. Okay, then third part is between 40 to 70 marks. Okay, then fourth one says 70 or more. Okay, so these are the answers. So again, I'll first step, I think now everybody is clear how to do it. So first we'll write down total number of outcomes, so those are given as the number of students are 90, so this will be 90. And then I'll write down my formula. So probability of an event is equal to number of favorable outcomes by total number of outcomes. Okay, then we'll move to each part. So first part says less than 30. Okay, so how many students have got less than 30? So this is between 0 to 20 and 20 to 30. So I have to add both of these, right? So 10 and 7, 17. So number of favorable outcomes is equal to 7 plus 10, so 17. Okay, so probability that a student has got less than 30 marks will be equal to 17 by 90. That's my answer. If I move to second part says 60 or more marks, right? So 60 or more marks. So my number of favorable outcomes here, we have to see the table. So number of favorable outcomes for 60 or more, so that is equal to 15 and 8. So these two will be added. So 15 plus 8, 15 plus 8, so that is equal to 23. So probability of a student getting 60 or more marks is equal to 23 by 90. Okay, then I move to my third part. So third part says between 40 and 70. So between 40 and 70 marks. So number of favorable outcomes again. Number of favorable outcomes are between 40 and 70. Okay, let's see the table. So between 40 and 70, so it starts from 40 and till 70. So this will be included for my third part. This was second part, right? Okay, so third part, 20, 20 and 20, 20 and 15, right? Okay, so number of outcomes are 20 plus 20 plus 15, so that is equal to 55. So probability of students getting marks between 40 and 70 will be equal to 55 by 90. That's the answer. Okay, let's move to the fourth part. So fourth part says 70 or more marks. Okay, so now again, number of favorable outcomes. So we have to find out number of favorable outcomes. So number of favorable outcomes of 70 or more marks. So 70 or more is 8, correct? So only 8 we have, so is equal to 8. From the table we figure out. So probability of a student who will get 70 or more marks is equal to 8 by 90. So 2 4s are 8 and 45 times. So 4 by 45 will be my answer. So when you follow all these steps, then you get complete 4 marks for this question. So you have to write down all these things. The formula is important and everything. Right, guys? So we have done this test. I think you enjoyed doing this test with me. And that's fine. Enjoy.